Number 1 out of the textbook, when they give us g of x is equal to 4 times the quantity of x, and it's plus 1, not minus 1. I wrote it down wrong. What we need to be thinking in our mind is that f of x equals x cubed looks like this. Okay? And so now what does this whole thing do? So this is written in the form f of x is equal to a times x minus h raised to some power, and sometimes we have a plus k. And so what happens is a does what? We should know this by now. It either stretches or shrinks vertically. H, on the other hand, shifts or translates, that's the fancy geometry term, horizontally left or right. And if we're lucky enough to have a plus k, what does that do? Well, that translates, I don't know what's so funny about that. Did my voice crack again? Up or down. Okay? So when I look at this function, g of x, the first thing I want to think of, and I'll do this with the first thing I want to do is I want to think f of x is equal to x cubed, and that's going to kind of go in and look like this. Now to graph this thing by hand without using a calculator, I pick a point. This is the origin. So that's where it crosses the x-axis. I don't have a vertical shift because I don't have a plus or minus on the outside over here. So I'm not going to shift up or down, but I have a minus 1, so I'm probably going to shift 1 unit over here. So my new origin is here. Now if I pick, in my mind I'm thinking, okay, so I'm going to horizontally shift f of x in a way that it kind of looks like this, and maybe it'll come around here, I don't know, we'll see. So now if that's the case, what is the 4 going to do? Well, if I had 2 imaginary points on the graph, it would be 4 times further away. So I'd be way up here and way down here. So that means that my new graph should look something like this. Okay, and I could be off a little bit, so I'm sketching it by hand. What would this point be right here? Well, this point here should be negative 1, 0, because this point here on the original function was 0, 0. And that's pretty much it. Well, let's graph it and see. Let's compare the two. So I'm going to pull up my fancy Texas Instrument calculator, because that's the only one that you can use on the ACT. Although sometimes we like to use the one on my website because it does a few extra features, like tells you the domain and range and stuff. So let's see what we have. So I have the parent function in this case is x cubed, and then I'm going to say 4 times the quantity x plus 1 raised to the 3rd power. It's pretty accurate, isn't it? You guys should be able to do that at some point in time. Does anyone have any questions? No? Good.